Good morning, everyone. This is Genesis 3rd BSc Maths, SCP Jain College, Minju, Department of Mathematics and IQAC of Sri Chandraprabhu Jain College in collaboration with Sri Chandra Sagendra Saraswati Vishwa Mahavidyalaya Kanchipuram. Kindly invites you all to the state level webinar series on Vedic Mathematics. Yesterday webinar was grand success. The resource person Dr. K. Bharati, Assistant Professor, delivered a talk on square and square roots using Vedic methods. Today is the third day of the webinar series on Vedic mathematics. Now, Dr.A.Dhanalakshmi ma'am, Assistant Professor, is going to present cubes and cube roots using Vedic methods. Now, I call upon R. Monisha, second BSc Maths, to give welcome address.
Good morning to all of you. It is my pleasure to welcome all the participants today for the webinar on the topic cubes and cube roots using Vedic methods. I welcome the eminent speaker Dr. A. Dhanalakshmi ma'am. Share knowledge with us. Welcome you ma'am. I also welcome our secretary sir, director B. Nagajodi sir, principal N. Sujata ma'am, HODs and faculty members for this webinar. I would like to welcome all the participants who are excited to hear ideas on the topic of discussion. So let us have a great session ahead. Once again, I welcome you all. Thank you.
Thank you, Monisha. Now I call upon S. Muthukumar sir, head of the Department of Mathematics, to give an introduction speech of our chief guest. Please, sir.
Thank you, Jesus. Good morning to all. Our Chief Guest Dr. Dhanalakshmi, Assistant Professor, SCSVMB, Kanjipuram, completed her UG in Pachepas College for Women and PG in Annamalai University. She did her MPhil in Alakapa University and PhD in SCSVMB University. She has qualified SET exam in the year 2017. She got 19 years of professional experience. She published 15 papers in national and international journals. She presented 29 papers in national and international conferences. She attended 97 workshops and conferences. She also organized 4 workshops and conferences. She has 12 invited talks. She also guided 16 MPhil students. She received Young Woman Mathematician Award from Infinity Awards 2020 organized by Ratnam College of Arts and Science, Coimbatore, held on 22nd December 2020. She also received an award of honor and recognition for achievement on maximum authors contributing for a book on the COVID-19 and its impact, organized by ESN publication on 13th of January 2021. Thank you, ma'am.
Thank you, sir. Now I hand over the section to Dr. A. Dhanalakshmi ma'am. Please, ma'am.
Thank you, ma'am. Good morning to all. Is this my voice audible?
Audible,
Hello.
ma'am.
Okay, thank you. And once you check is my screen visible? Can you
Yes,
see my
ma'am.
screen?
Yes, ma'am.
Okay. Thank you. So, good morning to all. Thank you for the invitation. So, in this webinar series on Vedic Mathematics, today I'm going to take cube and cube roots. I'm Dr. A. Dhanalakshmi, Assistant Professor of Mathematics, Sri Chandrasekhirendra Saraswati Vishwa Mahavidyalaya. So today we are going to see cube and cube roots using Vedic mathematics. Generally, we know how to find cube and cube roots of a number. But using Vedic mathematics, it simplifies the method and it gives the value easily. Okay, so today we are going to see cube and cubic roots using Vedic methods. Okay, so generally in Vedic mathematics, there are 16 sutras and 13 sub sutras. Using those sutras only, we are doing problems like multiplication, addition, subtraction, square root, cube root, whatever it is. So on this 16 and 13 sutras, I'm going to use two sutras today. Okay, so cube of a number. So I'm going to use the first sutra is Anurubhyena Sutra. The Upasutra, actually out of 13 Upasutras, one of the sutra is Anurupyena. It means proportionality. Using this proportionality, only we are going to find the cube of a number by method 1. So the cube of a new number is calculated using this Anurubhyena Sutra of Vedic Mathematics. So if you want to find cube of any number, first we should know the cube of 10 natural numbers. So cube of first 10 natural numbers, we know that 1 cube is 1, 2 cube 8, 3 cube 27, 4 cube 64, and so on up to 10 cube 1000. So these we should know. Okay. So if we know these cube of first 10 natural numbers, we can find 2 decimal numbers cube, 3 decimal numbers cube, 4 decimal number cube, whatever it is, we can find easily by Vedic methods. So first we'll find cubes of 2-digit numbers. Using this Anurubhyena Sutra, we can calculate the cubes of the numbers from 11 to 99. Okay. So if what is the thing first we have to notice, these cubes of number, whatever we see, the first 10 natural numbers, the last digits, it is unique. It won't be repeat. Any number of the cube, the last digit, unit place number, it won't be repeat. So all the cubes of numbers, every cubic number is unique, which means the last digit, one place. Okay, so it won't be a repeat. So this is useful for finding the cubes of higher order or 2-digit numbers easily. Okay, so we know the formula. This is the formula a plus b the whole cube, but we are now going to use the formula. We are going to use the proportionality, which means here we are going to take the ratio. What are the ratio? Na? This b by a. Here what is b, what is a? Na? Generally, if you want to take two decimal number, na, the first number means unit place is b, 10 place is a. That way only we are going to take, which means a b the whole cube. That way we are going to take. Okay, so first we are going to find the 10th place, that is a cube, and we are going to multiply by b by a, that is the ratio, and then we are getting the second term. After using the second term, if we multiply by b by a, we are getting the third term. Last term should be b cube. First term should be a cube. Last term should be b cube. Second term a cube into b by a. Third term, whatever the second term we are getting, that into b by a. Okay, so I'll show that here. So we are going to calculate 21 cube, which means here AB cube, where A equal to 2 and B equal to 1. That way we have to take. So here B by A is 1 by 2. So that is the proportion we are going to use here. Okay. So A equal to 2, B equal to 1. B by A is 1 by 2. A cube is 1. Here AB. So B cube is 1. A cube is 8. So first row, we have to take a cube, 8 into this b by a, 8 into 1 by 2, which means 4. Again, the third term should be 4 into 1 by 2, 2. The last term should be b cube. A is 2, a cube is 8. First term a cube, last term b cube. Okay, this is the first row. In our second row, we should leave the first term and the last term. In between term, whatever the first term it contains, we have to multiply twice it. 4 na 8 here, 2 na 4 here. Okay, so now we are going to add it. Okay, so from the last digit onward, 1, 2 plus 4 6, 4 plus 8 12, 2 here, 1 carry over here, so 9. So the cube of 21 is 9261. Okay, here we are using the proportionality 1 by 2, that proportion only we are using here. Okay, so the second problem is 35Q. Why I choose this problem now? In the previous problem, we don't have any carry over in the last digits, but here we should have some carry over. Okay, so here we are going to find 35Q. In this problem, A is 3 and B is 5. So 3 cube is 27 and 5 cube is 125. That's why only I said when I start the cube of a number, we should know the first 10 natural numbers cube. Then only we can do it. Okay. So now A is 3, B is 5, A cube is 25 and B by A is 5 by 3. Now we are multiplying the proportionality 5 by 3 by A cube. So first value is A cube. The last digit should be B cube. In between, 27 into 5 by 3. 27 into 5 by 3 na 9. 9 into 5, 45. Again 45 we have to multiply with this 5 by 3. So when I multiply 45 into 5 by 3, I am getting 75. Okay. So first and last. Okay. Second row should be, I said, leave the first term and the last term and twice the second and third term. So twice of the second term is 90 and twice of the third term is 150. So we will add it. Okay. So when I add it, here we'll get 125, this 225, and here it is 135, this is 27. We should not write as it is. We should take the carry over. So last digit only we are going to take here. First we have to take 5 only from this and 12 we have to take carry over. When we add this 12 with this 225, I'm getting 237. So in this 237 only, in 237 we have to take only the 7. We should take the 23 carry over. When I add this 23 with this 135, I'm getting 158. So I'm going to take 8 only. So the 15 is carry over. So 27 plus 15 is 42. Okay. So we have 42875, which means 42,875. That is the cube of 35. So here we should follow the carry over. In the previous problem, we don't have any carry over, but here we have the carry over, that we should keep it in our mind. Okay. So in this way, we can find the cube of two-digit numbers from 11 to 99 using this Anurupiena Sutra, which means the proportionality B by A. Okay. So these are all the few problems in this Anurupiena method. Whatever the method, the answer is same. So next is method 2. Okay. So in this method, it is like the formula whatever we saw previously. So we know that AB cube equal to A cube, 3A square B, 3AB square and B cube. But we'll add all those things. But here we are not going to add all. But these terms should be differentiated or distinguished by some vertical lines. Okay. So I'm going to take A cube, 3AB into A, 3AB into B and B cube. So as it is, in whatever the way we used in the first method, same way the first term is A cube and the second term is B cube. Given decimal, what we want to find the cube is AB. So AB cube, the first term should be A cube, the last term should be B cube. Okay. So here what we are going to do now, A into B with 3. We have to multiply. Okay. So if we want to find 23 cube, in this problem, A equal to 2 and B equal to 3. So 2 cube is 8, 3 cube is 27. So how we have to find now? 2 threes are 6, 6 threes are 18, because we are going to find 3AB. 18, 3AB is 18. 18 into 2, that is the second term. 18 into 3, that is the third term. That way we have to calculate. Okay. So AB, first we have to multiply AB that with 3. Okay, so if you find 3AB now, afterwards the second term is 3AB into A and the third term is 3AB into 3, which means in this problem 3AB is 18, 18 into 2, that is the second term, 18 into 3, that is the third term. Okay, so in this term, we should not add anything. We are going to take the carry over, simply taking the decimals only. How we are going to take the decimal? So here the last decimal is 7 and 2 is carry over. When I add with this 54, I'm getting 56. So 656, 6 is the decimal we should use, 5 is the carryover. When I add with 36, 41 is the number. We are going to use 1 as our decimal and 4 we are going to take carryover. 4 plus 8 is 12. So for this method, the cube of 23 is 12,167. Okay. Now we'll see the same method, 54 the whole cube. See here, A is 5 and B is 4. Okay, so A cube is 125 and B cube is 64. Okay, so and next term, I told you that we have to multiply this AB. 5 4s are 20. 20 into 3, 60. That is 3AB. Okay. So 60 with the 5, that is the second term. 60 with the 4, that is the third term. Okay. So 60 with the 5 is 300. 60 with the 4 is 240. So as it is, we are going to take the decimal using the carry over. So here we are going to take 4 and 6 carry over. 6 plus 240, 246. 6 we are going to take and 24 carry over. 300 plus 24, 324. 4 is the decimal and 32 is the carryover. So 125 plus 32 is 157. Okay. So this is the cube of 54. Okay. So this is the second method to find the cube of a number. These are all the some problems in the same method. The next, I told you, 2 sutras we are going to use. First, I used Anurudyena Sutra, and second, I'm going to use Yavadunam Sutra. Okay, so which means whatever the extent of its deficiency. Okay, so here we should find close to the base of 10, which means close to the base of 10. First 10 square will take. 10 square, if I take the base, means 100. 100 base, I can find from 91 to 100 or else from 101 to 110 very easily. So I'm going to take the base 100. Not only the 100, I'm taking the base 10 cube, 1000 also, 1000, 10,000. So if it is 100, 2 decimal number, 3 decimal number, 1000, 3 decimal number, 4 decimal number. So those numbers we are going to find the cube. So here we are going to take two cases. One is when the number is close to greater than 10 power n, greater than 110 square if I take 101, 102 till 110. Next is less than 10 power n. Suppose if I take 10 square 100, less than 100 it will be 91, 92, 93 till 99 we can find it should be close to the decimal places. Then we can find these cube of that numbers very easily. Okay. So first we'll see the case one when the number is close to and greater than 10 power 10. Okay. First I'll take one number greater than 10 square 100. I'll take here. So I'll take 1 or 2 cube. So whatever the methods here or whatever the steps we are going to follow. First we have to take whether this is more than 100 or less than 100. What is the surplus or deficiency? Here we have the surplus for 100. So here 2 is the surplus. If it is deficiency, suppose I'm taking 98 now, we will have the deficiency. So that time we have to take deficiency. So first here we take base 100, surplus is 2. So there are three parts. We'll take part 1, part 2, part 3, which means the cube of a number. Answer should contain 3 parts. So first I'll find the part 3. This is the last decimal, unit place. Okay. So how we are going to know as it is. What is the surplus? That cube. Okay. So here 2 cube is 8, which means surplus cube is 8. And that is a very simple part 3. But for finding part 2, we are going to follow 3 steps. Okay. But according to the surplus only, we are going to do these 3 steps. Okay. So what are the way or what are the steps we are going to follow? We will see. First, whatever the surplus we have, that into 2. Surplus into 2, 4. So the answer into that surplus means answer plus that surplus equal to 6. Answer is 4. 4 plus 2, 6. Now this answer into 2, the same surplus equal to 12. So these are all the 3 steps we are going to do. First step is surplus into 2. Second step, whatever the answer we are getting, that plus the surplus. Third step is whatever the answer we are getting, that into the surplus. Okay. So part 1. So part 3. Here the part 3 over, part 2 over. Now we'll go for the part 1. So what is the part 1 now? The surplus into 2. Again I'm getting 4. And whatever the value or is whatever the cube decimal means cube of a decimal we want to find, that number plus the answer, that gives 106. Okay, now we'll arrange the values part 1, part 2 and part 3 value. So part 1 is 8, but this is 2 decimal number, so we have to write it as 08. If it is 3 decimals, the 3 decimal number now 00 we have to add it. Okay, so here we will add 08. In part 2 we have 12, as it is we'll write. In part 1 we have 106. Okay, so now the cube of 102 is the first 106, second 12 and third 08. Okay, so as it is the way we have to write the decimals or arrange the decimals. Okay, if it is more number, if it is 2, this is we are taking 2 decimal number as our base. The 4 means 100, 10 power 2. So I'm taking 2 decimals. Suppose more than 1 decimal if we have now, that only we have to take our surplus. Okay, so we should not take even if it is 2 decimal number now, we should not take that as the surplus. Okay, so now we'll see one more example. In that 7 is the surplus. So part 3 is 7 cube 343 and part 2 surplus into 2. Next answer plus surplus, answer plus surplus, and third answer into surplus. So surplus into 2, first step, answer plus surplus, third step, answer plus answer into surplus. This is the part 2 value, but in this part 2 value we have 3 decimals, but in the previous problem 2 decimal. So in this problem we have to take one only the 47, one we should take carry over to the first decimal, which means part 1. Okay, so part 1 is the surplus into 2, 4. Next, whatever the answer we need, we want to find cube of that number 107 plus 4, which gives 120, 14, sorry, 14. So which gives, here 7 into 2, 14. So 107 plus 14 equal to 121. So now we arrange the decimals. So part 1, 121, part 2, 147, and part 3, 343. So how we are going to take the number now? In part 3, 43 only we are going to take, 3 is the carryover. So only 2 decimal place we have to take, and 3 is carryover. 150, here we are going to take only 2 decimals. 50, 1 is the carryover. So 121 plus 1, 122. So the cube of 107 is, okay. So now we'll see the case 2. Case 2 na, two decimal number, when it is less than 10 power n, which means 10 less than 100 will take, 10 square first will take. So less than 100 na, from 91 to 99 we will find it. Yeah. So first example, 92 cube, we'll find 92 cube. But in the previous case 1 we had surplus, but here we have deficit. Okay, so what is the deficit? Is minus 8. So that we will take it. So minus 8 is the deficit here. Next, as it is part 3, minus 8 the whole cube is minus 512. We should consider negative sign also. So minus 8 the whole cube is minus 512. And part 2, that whatever the deficit into, whatever the way we followed for the case 1, the same way, but we should consider the sign also. So deficit into 2, answer plus deficit, answer into deficit. Here minus into minus plus. Okay. And part 1 as it is, deficit into 2, answer plus the given number. So 92, here the answer is minus 16, so 76. Now we will arrange the numbers. Okay, so part 1, part 2, part 3. First we will take here minus 512. But here minus 512, last to 2 decimals we are going to take. But when we take last to 2 decimals, this is negative, minus 512. So here I am taking this minus 12 as bar, 12 bar, which means 100 minus 12. This 12 bar I am going to calculate 100 minus 12, which is 88. Okay, so I'm going to take here 88 only. This minus 5 is carry over here. Okay, so minus 5 carry over here. Part 2 is 192. That carry over minus 5, which gives 187. And here we have, see, 88, and this 187 minus 1. So we'll get, because this 12, 100 I'll take, so I have to subtract 1. If I take 100, that 1 I have to subtract, so I'm getting 186. So in this 186, we'll take the decimal 86, 2 decimals. So 1 is the carryover. So part 1, 76 plus 1, which gives 77. So cube of 92 is this one. Okay, so here we should consider the negative symbol, that we should not leave. But when we have surplus, that problem we won't get. Okay, but when we get this deficit, we should consider the sign also. Whenever we should use this deficit, that places we should consider the sign. So when we see one more example, I think you'll get it. So now we'll find the 95 cube. Here deficit is minus 5. Okay, so base 100, deficit is minus 5. So part 3 na, minus 5 the whole cube is minus 125. Okay, and part 2, deficit into 2, deficit plus answer, answer into deficit. Okay, so part 2 it contains 75. Part 1, we have deficit into 2 and the given number plus the answer. Here the answer is minus 10, so instead of adding we'll subtract it. Okay, now we'll arrange it. So part 3 will have minus 125, but we will take this as 25 bar, which means 100 minus 25, that is equal to 75. So minus 1 one surplus, and for 100 we'll take one more one. So both we have to subtract it. Here 1 minus 1, for 100 we'll take 1 minus 1. So minus 2 we have to subtract. Okay. So we will arrange it. 75, 2 decimals only we have. 73, 2 decimals only we have. If more than 2 decimals now, that we should take it as carry over for the previous part. Okay. So we'll get 95 cube. So when we have the base near to 100, now we'll take 2 decimals. Suppose the base near to 1000, now the same process, but when we take 3 decimals, we will take it. Here we take 2 decimals. Now instead of taking 2 decimals, we'll take 3 decimals. Otherwise, the process and all same. Okay, so everything is same. We should not have any different or any new methods. So we should have the same method, but instead of taking 2 decimals, we'll take 3 decimals. Okay. And if it is 10,000, now we'll take 4 decimals. 4 decimal, previous decimals, we have to take it as carry over mode. Okay. So next we'll find cube roots of exact cube. Okay. So how we are going to find the cubes and cube roots? Mostly by inspection and augmentation. The lowest first 9 numbers cube. Already I told you that 9 natural numbers cube we should know. So here the ending should be different or unique. That is the thing we have discussed in this session first. So in this method, in this unique last digit gives the cube roots. But here one thing, we are going to find the cube root of the exact cubes only. Okay. So when we have exact cubes, now we can find the cube roots. Okay. So generally we'll see now cube end in 1, and definitely its root also end in 1. Any number if you want to take cube root na, if it's ending 1 na, definitely its cube root is also 1. If a cube ends in 2 na, definitely cube root ends in 8. Cube ends in 3 na, cube root ends in 7. A number we want to find cube root, its last digit is 3 na, definitely cube roots end last digit is 7. So if cube ends in 4 na, its cube root ends in 4. If cube ends in 5 na, cube root ends in 5. If cube ends in 6 na, cube root ends in 6. If a cube ends in 7 na, cube root ends in 3. If cube ends in 8 na, its cube root ends in 2. Cube ends in 9 na, cube root ends in 9. Between some numbers we have the same endings: 4, 4, 4, 1, 4, 5, 6, 9. These numbers having both cubes and cube roots ends the same number. Okay. But 2 and 8 complement. 2 and 8 complement. 2 na 8, 8 na 2. And 3 and 7 complement. If cube ends in 3 na, its cube root ends in 7. If cube ends in 7 na, its cube root ends in 3. Okay. So these are all the complement. Okay, so these things only we have discussed in this slide. So now we'll find the cube root of some numbers. Okay, so here when we get some number, if we want to find the cube root, then we have to group these numbers from right to left, from last to front. Okay, so how now we have to group three decimals from last to left to right to left. Okay, so here we'll group from last in 728, that is the first group, and 1 is the group. 2 groups we have split up here. So first what we have to see now, we want to find the cube root of the last group, which number it ends in. Here it ends with 8. Already we saw that if a number ends with 8 na, its cube root ends with 2. If a number cube ends in 8 na, its cube root ends in 2. So definitely the cube root of 728 ends in 2 only. So the cube root using this number we have to see that that is 2. And the cube of 1, the cube of 1 is 1 only. Okay, so the last digit is 2 and the first digit is 1. So the cube root of 1728 is 12. Okay, but we should have some exact cube only. We should not find whatever the number using this Vedic mathematics methods. Okay, next we'll see the another number. We'll group from right to left. So we have 2744. We'll take 2 separately and 744 separately. Okay, so in this group, again the root of this number, if we have two groups now, its cube root, definitely it's a two decimal number, that we should keep it in our mind. Okay, so first we will decide for the last group. When we take the last group, it ends in 4. So already I told you that if a number, if a cube of a number ends in 4, it cube root ends in 4. So definitely the cube root of 744 should ends in 4. Okay, next the first group, will see the first group contains only one decimal 2. Okay, but previous problem we had simply one cube is 1, so directly we took. But in this problem we have 2. How to find the first decimal? Last decimal 4 confirmed, there is no doubt, but in the first decimal we have to take 2. Okay, so which is the cube of the number less than that and greater than that we have to take. If suppose 2 now, 1 cube is 1, 2 cube is 8. So this number lies between 1 and 8. Okay, so more than 1 cube and less than 2 cube. So we'll take lies between 1 and 2. So whatever the lesser number, that only we have to take. We should not take here 2 cube. We should take only the lesser number. So I'm taking here 1. Okay, because we are taking the cube root. So we will take here 1. So from this group, the last digit cube root 4 and the first digit is 1. Therefore, here we'll conclude that the cube root of given 2744 is 14. So what is the thing now? The last decimal is plays major role for finding the cubes as well as cube roots. So that we should keep carefully seeing that while we are finding any cube or cube root. Okay, and now we'll take in the previous problems whatever we saw, when we have the two groups in the from here to here, in this it contains only one decimal, but here we'll have two decimals. But as it is two groups only, okay, one group it contains 648 and the other group it contains 10. So here the cube ends in 8. So its cube root is ends in 2. I told you that 2 and 8 are complement. If your cube ends in 2, na, its cube roots end in 8. If your cube ends in 8, na, its cube root ends in 2. So both 2 and 8 are complement, and 4, what is it? 7 and 3 are complement. So here the number, this number, whatever we want to find the cube root, it ends in 8. Therefore, definitely its cube root ends in 2 only. So we fix the last digit, the cube root of the last digit number 2. Definitely cube root, it contains the last digit is 2 only. So when we concentrate on the first digit, we have in this first group 10. Already we have discussed in the previous problem this 10, where it lies between 1 cube na 1, 2 cube na 8, 3 cube na 27. So definitely 10 is lies between 2 cube and 3 cube. So here, which is a smaller one? Here 2 cube is the smaller one. So we'll take smaller number is 2. So the first digit of a given cube root is 2. So in this we have the cube root of given 10,648 is 22. So that's why only I told you for the first 10 natural numbers cube we should know, then only we can find easily other numbers, either cube root or cube. Okay, so here the second group, consider second group beside the second last digit of the cube root, and the first group will decide the first digit of the cube root. Here we have in this number we have 5 decimals, so we split it as 3 2. Okay, here itself also 3 2, same as 656. Last digit is 6. If it is last digit 6, then definitely its cube root ends in 6 only, because 4 4 6 6 5 5 1 1 9 9. So these numbers 1 4 uh, 5, 6, 9, it contains cubes, and cube roots are same in numbers. Last digit is same. So in the second root, it ends 6. Therefore, its cube root is also ends in 6. Okay. So we have to go for the, we have to decide which is the first decimal of the cube root. Here 46 we have. So 46 now we should go for 3 cube and 4 cube. 3 cube is we have 27, and 4 cube is 64. So between these only we have the 46. So about these two numbers, 3 is the smaller number. So we can easily decide that first decimal should be 3. Okay, so here the cube root of 46,656 is 36. Okay, so here we have 3 decimal number. So even the first group, it contains 3 decimal number, and second group is also 3 decimal number. Here last digit is 7. If the last digit is 7, its cube ends in 3. Because 7 and 3 are we have the means, if a number ends in 7, its cube root ends in 3. If a number cube of a number ends in 3, its cube roots ends in 7. Both are complement. So if a cube of a number ends in 7, definitely its cube roots ends in 3. So in this decision, the last digit of the cube root of given number should be 3. So when we concentrate the first number, first digit, we have to go for the first group. What is the first group? 804. So that should be lies between 9 cube and 10 cube. So in this 9 cube and 10 cube, the smaller number is 9. So the first decimal of the cube root of the given number is 9. So the overall cube root is 93. So the cube root of 8,04,357 is 93. Okay, so these are all the problems, extra problems we can find. We can easily find the 2 decimal numbers. Here itself also 3 decimal numbers also we can find. Means the cube root should be the 3 decimal number. Whatever it is, we have to group 3 3 from the last. We have to 3 3 from the right, we have to group 3 3, whatever it is. So in this process we can find the cube roots. If and cube of a number ends in 3, now its cube root ends in 7. Cube root of a number ends in 5, now its cube root ends in 5. If cube root of a number ends in 2, now cube of a number ends in 2, now its cube root ends in 8. If cube of a number ends in 9, definitely its cube roots ends in 9. So in this way, we can easily find the cube roots of exact cube. That I will tell you. So these all, if we practice these problems, we can find the cube of a number and cube root of a number very easily. Some mental calculation also. When we say see here only, first when we do starting, you may take this is the calculation. But if we practice now, we'll get mentally we can easily work it out within few seconds. These problem, but we should practice in this way. If we are often practicing now, will do easily the cube and cube roots very easily. Okay. So thank you. Is there any doubts? Hello, sir.
It's take more time for us to find cubes and cube roots of the numbers. Now we can understand by applying Vedic methods that using different formula, it is easy for us to calculate cube and cube roots of any numbers. Thank you, ma'am.
Thank you.
Participants, if you have any questions, put into the chat box.
Is there any doubts?
Hello, ma'am.
Ma'am.
Ma'am, this is Dr. Vijay Chitra.
Yeah,
Ma'am,
ma'am.
can
Tell
you
me, ma'am.
can you suggest any book for this, ma'am?
Yes, ma'am. We'll tell you, ma'am. Will tell you. I'll WhatsApp you. I'll
What's okay.
definitely. One book is there. That
Okay.
is the basic book for this Vedic mathematics. In that book only, it's starting. Okay, Bharatiya one author name is. I'll suggest
Okay,
you.
ma'am.
I'll
You
take the
can.
number from
Uh,
Vijayalakshmi, ma'am. I'll tell you, ma'am.
okay, ma'am. Okay.
Mm. Thank you, ma'am.
Thank you, ma'am. Thank you.
Thank you, participants. I call upon M. Lavanya, 3rd BSc Maths, to propose vote of thanks.
Good afternoon, good afternoon to all. I express my sincere thanks to the management for their constant support. My heartfelt thanks to our speaker, Dr.A.Dhanalakshmi ma'am, for her informative session. It's my pleasure to thank the director, Dr. D. Nagajodi sir, and the principal, Dr. N. Sujata ma'am, for encouraging us continuously. I thank all the HODs and staff members for supporting all times. Finally, thanks all the participants of this webinar. Once again, I thank one and all who attended this webinar. Thank you, ma'am. Thank you very much.
Thank you.